Hi, my name is Pearl, and we're going to be teaching this relatively simple question. So, they want us to design the ladder logic, and we're giving the steps. So, basically, they want when IO is turned on, there should be a memory bit that saves the state because it's a push button, and that memory bit will ensure that key on remains on, but for 3 seconds. So, we need a kind of timer. Now, after 3 seconds, we want a new memory bit to turn off Q naught and to power on Q1. Now keep in mind whenever we want to model start signals in PLC in ladder logic, it has to be a normally open contact. When we want to model a stop signal, it has to be a normally closed contact. We want Q1 to remain on for 7 seconds, so we need a timer. Then after 7 seconds, a new memory bit M2 will power off Q1 and essentially the whole system. So now we're simply going to start designing this. We have our first push button IO. IO is going to power on Q naught. But then you see the way a push button works is when you press it, it turns on, effectively powering on the output. But then once you release the push button, it turns off, go back to this state of zero, effectively turning off the system. So you need to find a way to save this state. That's why we add M1. You see when it gets powered, M1 also gets powered and current flows to the output. But then even if IO turns off, M1 will still remain conducting. Do you understand this? Now, just for the sake of simplicity, we're going to segment it. So the output here will be not M1, M naught. Now we want the output Q naught, which is controlled by this. Once M1 is energized here, so will this be energized Q naught. Now we want it to remain on for only how many seconds? 3 seconds. So we're going to put M naught into a timer. This timer will start the second it senses that M naught has come on. We're going to use an ONT timer. This is T1 ONT. Now the input is enable bit, the output is Q, the preset value, and the accumulator. The preset value is where you put the amount of seconds you want to count, and the accumulator is what counts 1, 2, 3, 4, 5, like 1 to 3. And then the output will be a memory bit M1. Now, this memory bit M1 is what will help to turn off Q naught and turn on Q1. So how do we make M1 to turn off Q naught? When this gets energized, its value becomes what? 1. Remember I told you that to model a stop signal, you draw it as a fairly close contact. So at this point, I'm going to do something. I'm going to include M1 at this point, but as a normally close contact. So when its value is 1, that is, it has been energized. Guess what? Once a normally close contact is energized, it goes from a normally close contact to a normally open contact, which effectively cuts off current from flowing to Q naught. It will cut it off. Now, how do we um model M1 such that it can turn on Q1? Simple. You model it as a normally open circuit. It's going to go into Q1. But you only want this to stay on for 7 seconds. After 7 seconds, you want it off. So we want a timer that as long as M1 comes on, this timer should start. So we're going to use an on timer. This is the EN, this is a Q, this is a preset value, and this is the accumulator. Now, the preset value is 7 seconds, I believe. This is it. Let me name T2, the turn timer. And the output is going to be M2. Now, what M2 does is effectively trips off the entire circuit. So in order to trip off the entire circuit, I'm just going to add it to the first circuit because the second this first circuit is turned off, nothing in this machine will be on again. So to model a stop signal again, we add it as a, I'm just going to erase this. We add it as a normally closed signal M2. The output is still MO, doesn't change. So now normally current be flowing, but the second it gets energized at this point, that has a value of 1. This normally closed will turn into a normally open, effectively turning off MO. MO would have never have turned on the motor and everything. So it just shut out the whole circuit. Now I have a simulation for this in case you do not understand what I've explained to you. Understand it in the simulation. So the simulation is going to be a little bit fast, but you can just see if you can get the idea of what I'm saying. I'm going to force this to be true, then false. You can see this was energized before. It started the timer. This energized cuts this off. M1 is not energized and it has started the timer. The second it energized M2. M2 came here and cut off the circuit. That's just how simple the circuit is. Thank you for watching. Hope you understood. Any questions you have, don't hesitate to leave them in the comment section. Thank you. And don't forget to like and subscribe.